How's it going, ladies and gentlemen? Mr. Donahue here again, this time taking a look at percent composition from chemical formula. Basically, what percent of water is hydrogen, and questions like that. So our objectives will be to determine the percent composition for each element in a substance given its formula. And this percent composition is always going to be by mass. We're concerned with the mass of each thing. Okay, so first things first, the equation. Percent composition is equal to the mass of the part divided by the mass of the whole thing times 100. Where the mass of the part is going to be the total mass from that element in the formula. So you got to take all the oxygens or something. If you wanted the percent oxygen, what's the mass of every oxygen? And the mass of the whole will be the mass of the entire formula, including that element. So if I'm taking a look at H2O, it's everything in there, the two H's and the O. So what is the percent of hydrogen in H2O? Well, so first thing we got to do is figure out, well, what is the mass of the whole thing? So the mass of the part is going to be just the hydrogen, right? So we have two hydrogens times the 1.01 mass of each hydrogen gives us 2.02. So that's going to be our mass of our part. So the mass of the whole thing is going to be equal to the mass of those two hydrogens and whatever else is in there, the one oxygen. So I look up the masses of the oxygen and I get the formula weight for the whole thing to be 18.02. So if I want the percent for hydrogen, it's going to be equal to the mass of the hydrogen, which I found to be 2.02, mass of all the hydrogens, divided by the mass of the whole thing. And the whole thing was 18.02. And you know the units, atomic mass units, which cancel out because they're dividing by each other, and then you times that by 100. And you get a final answer of, here I have it written down, 11.2%. So that's what you do. Figure out the mass of your part, divided by the mass of the whole thing, times by 100. So why don't you try some on your own? Here's a couple of problems that you can try. What is the percent of oxygen in H2O, and what is the percent of aluminum and aluminum oxide? All right, pause it, try some of those, and then go forth. Okay, welcome back. Let's check it out. So what is the percent of oxygen in H2O? Well, you could have done a couple of things. You could have looked at the first problem and thought that, well, hey, 100% of it is going to be equal to the hydrogen percent plus the oxygen percent. So you could have done, all right, well, 100 minus the 11.8, or 11.2 rather, 11.2% should give you the oxygen, which would have been 88.8%, which would have been perfect because the whole molecule is just these two hydrogens and that oxygen. So if you know the percent hydrogen, you can figure out the percent oxygen. But let's do it the math way. So the math way, the percent composition would be equal to mass of the part. So I got 1 times that mass of each oxygen, which is that 16, over the mass of the whole thing, which would have been the two hydrogens times the mass of each hydrogen plus the mass of that one oxygen. Right? And then that whole thing is on the bottom. So you would have gotten 16.00 over the 18.02 times by 100, which I forgot to have up there, but you know, and then you get the same answer, 88.8%. There you go. All right, what about the percent aluminum and aluminum oxide? Well, same process. Figure out, well, what is the mass of each aluminum? Well, aluminum, I look up its mass, and it is 26.98 AMU, and I'm going to times that by 2 because there's 2 aluminum, and I get a total of 53.96 AMU, and that's just for the aluminum. Now what about the oxygens? Well, the oxygen is going to be 3 times the mass of each oxygen, which is at 16.00, and I'm going to get 48.00 AMU. So when I add them together, that's going to give me the mass of the whole thing, which I found to be 101.96 AMU. So now the percent of aluminum is going to equal the mass of the aluminum, which we found to be 53.96. So we want all the aluminums in that formula, over the mass of the whole thing, which is at 101.96 AMU, and then times it by 100. And we get beep, bop, 52.92%. Cool. So, summarize. What's the equation for percent composition? Okay, you should know that. How do you calculate the percent composition? You should be able to do that. And that's pretty much the whole video, all right? So I hope you found that helpful, and I'll see you in class. Bring questions. Okay, bye.